Hello and welcome to this video. In this video we're going to be looking at the equation of a straight line. So the equation of a straight line in general terms will always be written in the form that y is equal to mx plus c. So this is a general formula that we can use to describe any straight line that we ever want to draw, where y is just the value that we're going to see on the y-axis. M is equal to the gradient, which we'll take a look at. What that means is essentially the slope. So if you have a very high gradient, it means you have a really steep line. If you have a very low gradient, it means you have an almost flat line. And we'll take a look at that in a minute. And x is the value along your x-axis coming across here, and c is your y-intercept. So that is the point where it crosses the y-axis. Okay, so for example, if I were to draw a straight line that went through the point here that was 1, my c, I would just have plus 1 at the end of my equation. Okay, so let's take a look at a few examples. So let's say we had a sketch. Let's try and sketch out a y is equal to 2x plus 3. They might give you this and they might tell you to identify what is the gradient and what is the y-intercept. Now the gradient m, we said it's y equals mx plus c, so m is 2 in this case, and plus c is equal to 3. Now what we instantly know about this is that it's a straight line, and that's given by the fact that it's in the form y equals mx plus c. We can draw it as a straight line, and we know that it passes through point 3, so it's going to pass through this point here. But how sloped it is, whether it's up here or whether it's down here, really depends on what this number is. And so we have to look into more detail of what is meant by the term gradient. So we said it's the slope, how sloped something is. So if you have something that looks like this, a line that goes up like that, that has a very steep gradient, so it has a very high value for m. And if we have something that goes along like this, maybe this is kind of almost flattish, so this has a very small gradient. You can also get gradients that do this kind of thing. These would be negative gradients, so it's kind of one of those things you have to almost be able to tell whether it's going to be big, small, or negative. And the way we define the gradient is it's the change in y. So it's the, if I take this line here, for example, the gradient is defined as the change in y here, which I'm going to note with this delta y. So gradient is delta y. This delta, this triangle delta just means the change in. So it's the change in y divided by the change in x. So it's essentially a rate of change. We're saying if we move across one step on the x-axis, how far do we actually move up on the y-axis? And that is the gradient. And so in this case, where we have a gradient of 2, it means that for every one step, so if I moved along 1, so let's say this is 0, if I move along 1 here, along 1 on the x-axis, it means if my gradient is 2, my change in y has to be 2. So when I get to here, this point here must be 5. Okay, because if I move along 1, I have to move up 2. Now, this is usually a good method of calculating your gradient, being able to work out this triangle. Usually you want to make these triangles, if you're doing this in science and you want to work out the gradient of a line because it might tell you a specific value, you want to make your triangle as big as possible. In terms of maths, because we're looking at lines that have strict definitions and they're not fit to experimental data or anything like that, we can just make a small triangle. So I would recommend the easiest way to do it would be to make a small triangle that goes 1 across on the x-axis and goes some value up or down. So it could also be down on the y-axis. Okay, and that will allow you, like I've just done, to, if you read across by 1, that tells you that the change in x is 1, and anything divided by 1 is just going to be the same. So that tells you that the change in y is going to be the same as the gradient if we just move across this by 1 unit. So how they might ask you to draw out these graphs, for example, if they wanted us to draw a straight line graph, in order to draw a straight line graph, we have to first know what the equation is. So let's say they gave us the equation that y is equal to 2x plus 5. Okay, instantly we know the gradient is 2 and the y-intercept is 5. Okay, so what they will usually give you, in order to make sure that you're getting and plotting the right coordinates, you'll have a table, and your table will consist of some x values, and they will leave the y values for you to fill in. And these x values, in this case, I'm going to go from -1 all the way up to 3. Okay, the values will usually be given in the question, so they'll usually give you this table. If they don't give you the table, then you basically have free reign to choose whatever numbers you want. I would usually go from -3 to +3. So as a side note here, -3 up to +3 allows you to get a good range. So you would say you'd want to fill in this table with -3, -2, -1, 0, 1, 2, 3, so that you can make sure that you're getting a full graph out of it. The reason I've only gone from -1 up to 3 in this case is just because I know this isn't going to be too interesting in the negatives. So there's not really much point going back too far. So how I would fill out this table is this x value in this equation has been given in the top row of this table. And so I need to find what is the value of y when x is -1. So we'll start with 0, because 0 is the easiest one, because the negatives can get a bit tricky sometimes. So if we start with 0, if we say y is equal to 2 times 0 plus 5, 2 times 0 gives you 0, and so y is just going to be equal to 5, which makes sense because this is our y-intercept. So we're saying that when the value of x is 0, i.e. we're traveling along the y-axis, a value of y must be 5. So this one we can kind of instantaneously know just by knowing the equation. Then we'd say y is equal to 2 times 1 plus 5. Now 2 times 1 is 2, plus 5 gives you 7. So this is going to be 7 here. Then we take y is 2 times 2 plus 5. That's going to give you 9, since this is going to become 4 plus 5, and that's give you 9. Now you can kind of already tell, to get from 1 to the next one, we're just adding 2 every time. So I'm going to assume here that I've got an 11, but let's always check to make sure. 2 times 3 plus 5. 2 times 3 gives you 6. 6 plus 5 is indeed 11. So this one up here was 5. Now if we wanted to do the -1, it'd be the exact same process. We just have to be a little bit more careful with working with the negatives, because if here we have -2 plus 5, I could actually rewrite this as 5 minus 2, which is going to give me a 3, which is what fits the pattern. So we're going up by 2 every time, and that's because our gradient is 2. So what we said before is if the gradient is the change in y over the change in x, and our change in x from 0 to 1 is just 1, then our change in y has to be the 2. Okay. Then from this, we could draw this line on a graph. So we already know, so in your exam there'll be properly labeled axes for you to draw on. This is just going to be a rough sketch here, but we'll look at some more accurate ones when we do the exam practice. So from 0, we already have this plus 5. If we wanted to go to -1, we know it's going to be about here, where we have a 3. Then the 0 is going to be on the 5. Then the 1 is going to be up here, about the 7. And then we're going to have a 9, where we have a 2. And you'll see that when we form these things, it will be a straight line. And so this proves that anything that we can put into this y equals mx plus c should always give you an exact straight line. And now you would take your ruler once you've plotted all your points and draw a line straight through all of your points, and you can extend it far past your points on either direction. So this is how we look at straight lines. This is how we can measure the gradient and also measure the y-intercept, and this is how we would attempt drawing a straight line graph in the exam. So that's straight line graphs. Thank you for watching. Hello and welcome to this video. In this video we are going to be doing some straight lines practice questions. So first up, we've got Bill uses his van to deliver parcels. For each parcel that Bill delivers, there is a fixed charge plus £1 for each mile that he has to travel. You can use this graph to find the total cost of having a parcel delivered by Bill. So this is a straight line, which means it will have some equation in the form of y equals mx plus c. Okay, and instantly we can read off what this plus c is going to be, because it's just this part here. So before we even read what the question wants, we know it's going to be mx plus 10. And the gradient here is going to be 1, since for each extra mile that he has to go, his cost is increasing by £1. So actually we know fully that our equation is y equals x plus 10. Okay, now we can answer the questions more freely now that we know the equation. So how much is the fixed charge? So the fixed charge, even if he doesn't have to travel any distance, is £10. So that's our y-intercept. So that's £10. Then Ed uses his van to deliver parcels. For each parcel Ed delivers, it costs £1.50 for each mile, but there is no fixed charge. Compare the cost of having a parcel delivered by Bill with the cost of having a parcel delivered by Ed. So Ed's equation is y is equal to 1.5 x, because for each mile that he's traveling, he has to add an extra 1.5. So if he was x is the number of miles, so if we have 1 mile, he pays £1.50. If he travels 2 miles, he pays £3. 4 miles, he pays £6, and so on. Okay, so what we could do, and there's no fixed charge, so we have a plus 0 here, but we don't need to write a plus 0. So what we can do is say, well, if we're traveling 10 miles and each of these miles costs £1.50, then 10 times £1.50 is going to give £15. So we can plot our first point about here on this graph. Our first original point would have to be the origin, since that's where it passes through 0. Then if we had 20, we'd be doubling that, so we'd be looking at £30. Then if we had 30, we'd be tripling that, so we'd be looking at £45. So we find 30 and 45. And then 40, we'd be quadrupling it, so we'd get 60. And you can see every time we add 10, we're actually going up by 15. So this is going to be 75 there. So we can actually draw along the same axes the two graphs. So this one here is Bill and this one here is Ed. And what we can say now to compare them is we can say under 20 miles the cost is the same. Sorry, not the same. The cost of Ed is cheaper than at 20 miles. Then we could say that at 20 miles exactly, their costs are the same. It should be the other type of there. There we go. Their costs are the same, and then after 20 miles, bill is cheaper. And that would be how we get to our answer. And this is because from up to the first 20 miles, Ed corresponds to a lower cost until we get up to 20, where they're exactly the same. This is where they cross over. And then after that, Bill is a lot cheaper than Ed. Okay, so now let's take a look at this next question, which is asking you to draw a graph of y equals a half x plus 5. So what we can say is, we know that if our equation is y is a half x plus 5, our gradient is a half and our intercept is 5. And usually when we have these things, we can always make a table. Okay, so we can make a table of x and y, and they've already given you in the question the limits of your things. In practice, you don't have to fully go through and do all of these things. I would say I recommend doing 4 or 5 just to make sure that you're getting the right thing, and then after that you can just extrapolate, i.e. just make a line fit the whole graph. So let's start with -1, we'll do 0, we'll do 1, we'll do 2, and we'll do 3, and let's not do 4. Okay, so we're going from here up to here, and then we'll see that we'd be able to expand the line either way. So what we can say is, if we put y is equal to a half times -1 plus 5, this becomes 5 minus a half, which is 4.5. I'm going to write it as 4.5. So this one is 4.5. And if we have 0, we already know it's going to be 5 because that's our y-intercept. If we put a 1 in there, we're going to get y is equal to a half times 1 plus 5, which is 5.5. This, when we put a 2 in there, y is equal to a half times 2 plus 5, and a half times 2 is 1, and 1 plus 5 is going to give us 6 here. And so you can tell, because this is a straight line, the pattern going up is always the same. We're adding whatever the gradient is. So 4.5 to 5, we've added a half, add a half, add a half. So this is going to be 6.5 as well. And then we just plot all of these points. So if we go to 0, 0 goes through 5. If we go to -1, we get to 4.5. And then if we go to 1, we get to 5.5. Then we go to 6, then we go to 6.5, then we go to 7, and then we come backwards, we'll go down to 4. And then we can draw a straight line through all of these points using a ruler, and that is your graph. Okay. Now with these questions, they can get a little bit trickier. So in this case, we're looking at 2 straight lines, so A and B. We've been given equation for line A. So A has been given as 2y is equal to 3x plus 8. Now you'll notice this is not currently in the form of yx plus c, because we have a 2 in front. We don't have any coefficients of y if it's a straight line. So what we need to do is make sure we get the 2 onto this side. So we need to move the 2 over, and that's going to give us that A corresponds to y is 3 over 2 x plus, and 8 over 2 becomes 4. So this is actually our equation for y. So it costs you 1 step to be able to figure out what the actual equation is. The line B, we've only been told that it passes through the point 1, 2 and 2, 8. And then we're just asked, do these lines intersect? Meaning, do they just cross over each other at any point? Okay. And to do that, the only way that lines can't intersect is if they're completely parallel. So only intersect if they are not parallel. So parallel meaning that we have two lines that look like this. Now, we're probably familiar with this idea. If we have parallel lines, they go like this and they will never ever touch each other. They're constantly always the same distance apart, and they're never going to overlap at any point. What that means in terms of mathematical expression is that their gradients are the same. The gradients are equal, because if I had things that go like this with this gradient, I need to have the same gradient going along so that they don't intersect. If I change the gradient, then they will have an intersection point here. So really what this question is asking is, are these lines parallel or not? And so what we need to do is really just find out what is the gradient of this. So we know the gradient of A is 3/2, but the gradient of this, we've just been given 2 points. Now you can think of these 2 points on a graph as you've got 2 and 8 up here, and you've got -1 and 2 maybe about here. Okay, and you want to find the difference between these 2 points. So what you could do is sketch out a graph like this and then work out what's your change in y and your change in x, and then divide the two. But you could also say that if you have a change in y, that's one of your y values minus your second y value. So I'm going to call this y2 minus y1 divided by x2 minus x1. Okay, now what this allows us to do, so this is the same as writing the change in y over the change in x, because we're just finding the difference between the y values and the difference between the x values. We can call one of these x1 y1 and one of these x2 y2. So I'm going to call this one x1 y1 and this is x2 y2. So I can then just substitute in the numbers. So y2 is 8, y1 is 2, x2 is 2, and x1 is -1. So careful with the double negatives here. But what this means is 8 minus 2 gives me 6, and 2 minus -1, if I have a minus and a minus, that becomes a plus. So this actually becomes 2 plus 1. So this is 3, which means my gradient is 2. And therefore, if my gradient of A is 3/2, but my gradient of B is 2, they are not parallel. And so we say, yes, the lines intersect because they are not parallel. And this would give us our marks for this question. And finally, we're going to go for a very challenging question. This will probably be at the very end of an exam paper, and it's going to push your knowledge to the limit in not just straight lines, but it's also going to add in some other things as well. So we're given A, B, C, D, and this is a square. What we know about squares is that all of these sides are going to be the same, okay? And they also all have right angles here. So P and D are points on the y-axis, and A is a point that's on the x-axis. And PAB is a straight line. The equation of the line that passes through A and D, so this line here, coming down here, is given by y equals -2x plus 6, and they want you to use that knowledge with the knowledge that this is a square and this is a straight line to work out this distance here, which I'm going to call x. Okay, so the reason this question is going to be difficult is because they've given us a minimal amount of information for us to use, and they haven't told us where the starting point is or any of that. So what we have to recognize is that this line here and this line here are actually perpendicular lines, okay? Now, something we know about perpendicular lines, parallel lines have the same gradient. The thing with perpendicular lines is if you multiply their two gradients, so this is the gradient of AD and this is the gradient of PA, it always gives you -1, okay? Or sometimes they'll refer to this as the gradient of a perpendicular line is the negative reciprocal, and that's because M1 must be equal to -1 over M2, reciprocal being 1 over, this is negative, so this is known as the negative reciprocal. Okay, now that we've got that and we have this equation, we can now work out what is the equation of this line. And with that, we can solve for a few things. So the first thing we need to do is to work out what is the coordinates of point D and what are the coordinates of point A. And so to do that, we can look at this equation. Okay, so this equation, when we're at point D, this is when the x value is 0, and when x value is 0, our y-intercept is +6. So we know that point D is actually 0, 6. Okay, now point A is the same, is on the same line, but now instead of the x value being 0, the y value is 0 because we're along the x-axis. And so we can have to put 0 into this and then solve for that equation. So we'd say that if y is equal to -2x plus 6 and y is 0, 0 is equal to -2x plus 6, and now we have to solve this for x. So I would move the 2x over to this side by adding 2x. So I'd get 2x is equal to 6, and therefore x is equal to 6 divided by 2, which is going to give you an answer of 3. So the point A is actually 3, 0. Okay, so now we know what these 2 points are. Now we can actually work out what the gradient of this PAB line is, and given that, we can then work out what its y-intercept is, and then we can find the difference between P and D. So using this perpendicular lines formula, since we know that the gradient of AD is -2, we could say that -2 times M2 is equal to -1, which would say that M2 is -1 over -2. The minuses can cancel, and so M2 is just going to have a gradient of 1/2. Now what that means is that our equation for PAB is going to have some form that y is equal to 1/2 x plus c. And now we have 3 unknowns currently in this equation, and we want to work out what c is, but to do that we kind of have to know what x and y are, which is why we had to work out the coordinates of point A, because we know A is a point that's on the line PAB. And so we can actually substitute in this is for our x value and this for our y value. And so in that case, y is 0, and that's equal to 1/2 times 3 plus c. So c is equal to -3/2. Okay, so this point here therefore has to be -3/2, and we know d up here is actually +6. So the length PD is the difference between them, so PD is 6 minus -3/2, which basically just becomes a plus, and then 6 we could write as 12/2 plus 3/2, and that becomes 15/2, which is 7.5. And that's solved for that equation. That is the length of PD. We just had to know some things about perpendicular lines, and then our ability to mess around with some of the straight line equations.
None of these toys on lease to made the whole year in a week to main chick out of their league to side chick out of their league to